Hi guys, I'm working on getting Home Assistant up and running in my house. In that process I decided to make this Raspberry Pi Pico test board in order to make some of my IoT devices with basic features such as relays, MODBUS interface plus temperature and humidity sensors. This is just the initial prototype, the final ones might be even smaller and include other cool features. In this video we will go through the whole process from making and designing the schematic to routing and ordering the PCB. The main features for this board are a Raspberry Pi Pico or any other variant, RS485 MODBUS interface, dip switch for MODBUS address selection, an SHT31 high precision temperature and humidity sensor, a quick connector, a power relay that can handle up to 16 amps, and a wide range input voltage from 8 volts to 24 volts DC, a reset button, user RGB LED, and a GPIO expansion header. For the mechanical side of things, we have 4 3.2mm mounting holes. The size of the board will be 80 x 80 mm, and it will be a 4-layer board design. Just before we start the project, I would like to thank PCBWay for making this video possible. Remember that there are a large section on PCBWay.com where you can find a lot of projects and inspiration from other makers. If you find a particular project interesting, then you can often directly order the PCB at PCBWay. You find my affiliate link in the video description of this video. Please use it and thereby support the channel. So remember to visit PCBWay.com. So let's dig into it. So here we are in KiCad 9 and let's dig into the schematic design. So the first thing I always do is to set up the page settings. So let's hit it in there. And we could insert the date and revision number 1.0. Title, that will be Pico. It could also be the wireless Pico RS485 interface. And I will call it IoT thingy. Like that. And company, that's made by Morten. And I think that the size could be A3 with all the parts that I need. Okay. And we can see all the things that we just inserted is also down here. So the major thing is to insert the parts. So let's place some symbols, and of course we need the Pico module, and we have one here. Let's insert that one. And we also need some power. So the one that I chose for this, I think I have a data sheet here. This is the Trago Power GSR1 2450, and it's very easy to use. You can input 7 to 36 volts and you get 5 volt out, and you can draw up to 1 amp. So this will be the one that I will insert in the project here. GSR, and we have it here. Like that. And one more important thing is the temperature and humidity sensor. That's SHT31. We can place it over here somewhere. And we need an RS485 transceiver. And that was the GHVD 1406 I chose. I don't have that, but we can take maybe a max 30. No, it's not present either. we can maybe take, let's say, this 34, that one. And what else? We need a DC power jack. Can take that one and insert it up here. So maybe we should concentrate here first and make the circuitry for the power input. Like that. And what we would like to do is to protect the input with a fuse. And it will just be like a polyfuse here. And we would like also a diode, a transformer. We will be able to put in here 8 to 24 volts, so we need like a 24 volt transformer here. And you can see what we have here in the library. There's no, we can just look for a diode then. And then we have different ones here. We could just take one of those. If we have an SMA, we can just take this one for now. Then we have the symbol. And then we would like to have a few capacitors, just decoupling the input. And capacitor. And we need to find the right library for that. And we can use the small, let's see here. This one. And one more on the other side. And you can just click here and then Control D for duplicate. Like that. And then we need a ground symbol. And we have this ground symbol here. And I would like this to be a bit closer, then just click here and press M for move, like that. So we will connect polyfuse and then go into the transformer. Like that. And then we need to put ground here on our input connector. Like so. And we could just make a bit more space here. And I want this part to be the SMA J24A. Like that. And we would like a 1 amp polyfuse. And we would like this capacitor just to be at 2.2 microfarads and the 50 volt type. and we want this to be a 10 micro and a 16 volt type. And we will connect this and just press W and move this accordingly. And also copy the ground symbols here. Like that. And let's connect this. And I would like to move this a bit. Just mark it and press G. Like that. And G. Then we can take this, Control D for duplicate. And we have all in line here. Duplicate this one. And V for wire. Like that. And I want this to be a bit closer like that. And also the designator. Like that. Like so. And let's put some power labels on. Place power. And we would like to have a 24 volt power net here. Wire. And then move this a bit closer. And duplicate, Control D. And over here we have our 5 volts. Plus 5 volts. And a wire. Like that. So now we have our input voltage 24 volts to 5 volts. And then I would like to go from the 5 volts to 3.3 volts. So the way I want to power the Pico is not by USB or anything. I just want it to be powered from this barrel jack. And then when we program it, we can just connect the USB power and leave this unconnected and then download the program. I can just show you a document here, hardware design with a RP2040. And we will use this way of connecting everything. We will just insert a voltage between 1.8 and 5.5 volts into the VSys pin. And if we want, we can take out 3.3 volts from the Pico itself, but it's limited in the current. So I would like to just add a LDO where we can draw up to 1 amp in total. So let's put on an LDO. So we will place the TLV1117 3.3. This is one of my favorite LDOs. And this one. And we need the 5 volt input. That. And I just want a 22 micro decoupling capacitors. And on the output, I want the same. And instead of 5 volt, I want 3 volt 3. And wire. Like that. and another ground pin here. So that's fine. 5 volt to 3.3 volts, 1 amp. And I would like an indicator, just a LED that we have 3.3 volts. So let's take the 3.3 volt power net, place a resistor and an LED. Small, like that. And we would like to place an LED. Like that. I think I have one defined in here. Like that. And I want this one to be green. And let's have a ground symbol. Copied, Control D. And then V for wire. And I would like this to be 1 kilo. Like this. Maybe this is fine. This a bit closer. Like that. So now we have the power, and let's concentrate a bit here on the Pico module itself and get things connected to this. So we have the input power, and we want to go into the pin VSys, and we want to do that via a diode. So let's place one of those. And I would like to take I need a Schottky diode of some kind. So I can find maybe 19. This one. And I would power that from the 5 volt power source. So let's grab the 5 volt power net, duplicate, like that. And if we want, in our design, we could just insert a resistor here on the 3.3 volt output, so that we can connect that to the 3 volt net. That's just if we don't place the LDO up here, then we can just replace it with a resistor. But then we have to take care of not using too much power. I think we can take out 300 milliamps from the Pico here, and that includes also the power that are used by the Pico itself. And if you have the Wi-Fi version, then you could maybe get into issues. So, but let's just have the option here. And take a resistor, we can just reuse this one. Like that. And we want it in the same place as the 5 volt. And I would like this to be just a 0 ohm resistor. Like that. And it should not be populated, so we can just put a mark here. And then we see that normally this is not assembled. So we need also to have ground. There's a lot of ground pins on the Pico. So we will just take a net down here. And copy one of the ground nets. Just move it up a bit, like that. And we can copy this to the other side as well. Like that. And then we need to connect the other pins. And the air ground, we also need to connect that. So now we have the power solved for the Pico. And the VBus is not used, and the 3.3 volt enable pin is not used either. And we don't use a reference for the AD converters. So let's see, we need to have a reset button on the Pico as well. This is not standard on the device, so let's just place one here on the run pin. And place a switch. Like that. And that will need to go to ground. Like so. Like that. And we would also like to have a 3-pin programming header for the SVD interface. So let's put on this 3-pin connector. And just route the signals over here. also put on ground label like that. Alright, so the other things that I need to connect, I would like to have some user I/O, I would like to have a user programmable button, and I would like to have an RGB LED. So let's put that stuff on here. We could just take a copy here of the switch and put it over here somewhere. And a wire like that. And I would like to have a debouncing circuit, so that I will pull it up to 3.3 volts and have a capacitor. So we can just take the symbol here and move this up a bit. And move this down. And let's grab this. Put it here. And the pull-up resistor should be like in the range of 10K. And we would like this to go into a signal, and we will label that, just press L and call that SV. And we need to find a pin on the Pico. Let's move it down here somewhere. And we could also just label this as run. Then we need an RGB LED. I think I have an RGB LED here somewhere. In my libraries. This is just small, this is this one. And let's connect the anode to 3.3 volts. Like that. And just have a 1 kilo ohm resistor for each. Can take this 1 kilo here, duplicate, rotate it, and rotate the designator, put it here, and the value approximately here. Like that. And duplicate this. And then we can call this label, and then call this LED blue. And we can put a label on this, LED green. And this will be LED red. And we also need these labels. And we can put them down here as well. Then make sure we have the right names. And I would like to have a dip switch for setting the correct address for the MODBUS interface. Then I'm able to select different addresses for my device. So let's place a dip switch. And I would like that to be the signals to be pulled up. So I'll just put ground here on one side. Like that. And then I want to go into the Pico. But I would like to have some pull-up resistors on each pin. And I would like some 4K7 resistors. This, and this should be 4K7. And that should be on all four. Like that. And we want the signals to go out a bit further. And let's put a label on those. Dip 1. Dip 2. Dip 3. 4, like that. Maybe they should go in one position more here. And let's copy these labels and put them down here. And one more thing I would like is to have an SPI port broken out on a small pin header. So that will be like a 10-pin pin header with some signals where we have some mains or 3.3 volts and ground, and then some SPI signals and maybe a couple of GPIOs. So let's place a connector. And I always have like ground here on the two lower pins. then let's take a ground symbol. And some 3.3 volts on the upper pins here. Something like that. And then we are ready for some signals here. And let's have some signals. We have 4 signals on the SPI port. And we would like to use speed 0 on the Pico. And we would like to have the master output. That's the TX. And I would like to maybe have it a bit further out, everything here. So let's try and move everything out. G, 2 more, like that. And also this. Like that. And we have the clock. And we have a master input, the RX. And we have the chip select. And then we have a couple of pins more that we need to populate with some GPIOs, but we will find those a bit later. And up here we have the temperature sensor and humidity sensor. And I would also like to have a quick connector. This is I2C. So this will be connected to the I2C port, and also the quick connector will be connected to the same SP or the same I2C port. So let's try to get this up and running. So the SHT31, it's quite simple. We have power, and we have an address select, and we have a reset pin, and this pin here called R is just going to be connected to ground, and we will not use the alert pin here. So let's see, we would like to have the SDA and SL signals on the other side, so we can just mark the part here, and we would like to say transform selection and mirror horizontally, like that. And we would like to have some power. Just move the labels over here, the reference designator here. So let's find a power symbol, and I just forgot this to be 100 nano. So we can take this decoupling capacitor and the power net. this wire 3.3 volts and place a decoupling capacitor close to the power pin. Like so. And we also need to put ground here, ground pin, and the R pin we also need to put a ground on that, so just press G, duplicate that one, like that. And the reset pin on this one is just connected to a pull-up resistor. And the address pin go out here. If we tie this low or high, we can select between different addresses. And I would just like to have this put low. So I'll need to find like a 10 kilo ohm resistor. And then pull it low here. And I would like to have like a solder jumper, so I can connect it to 3.3 volts. That. So then we can easily put a blob of solder here, and then it's connected to 3.3 volts. And we would like to have like a 10 kilo ohm resistor as well here on the reset pin. Can grab this, duplicate, so all we need to do now is to connect the SDA line and SL line, and the alert pin, we will not use that one, so you can just say place and no connect flag, then you know that you have decided not to connect anything to this one. So I would also like to have a quick connector, and this is just a 4-pin connector. Let's place a symbol for that one. So. And let's put some labels on here just to specify what we have. Place some text. So this is a quick connector. And on the quick connector we have ground on pin 1. And we have VCC of 3.3 volt here on pin 2. And on pin 3 we have SDA. and on pin 4, we have SCL. Like that. So we can connect ground. Just go down here. Let's find a ground symbol. And VCC will go up to a 3.3 volt net. And we will need like a 10 micro cap as well. I think we have one over here. Get this a bit closer there. Remove that. Put a wire in here. Like that. Then we have our SDA line. And we have our SGL line here, or SGL line. And we would like to connect SDA to SDA. SCL to SCL. And then we need some pull-up resistors. We could take some 4K7 as well. Let's grab these. Duplicate these. Get rid of those. Like that. And then we need to put some labels on. Let's grab C, SDA. Let's grab C, SCL. Let's copy those and put them down here. Like that. Let's remember to save the design. So the next thing we have, I think we would now put on the power relay. Let's move this down here in the end, take this last. Let's find the power relay. And this is quite a beefy relay, up to 16 amps, good quality. And we want to go out to a screw terminal with 3 pins. Like so. And we want the common pin to go into the middle. Something wrong here. Wire like that. And maybe we should move this a bit further back. Like that. And I would also like an indicator when the relay is activated. We would like to have an LED that shows that it's on. We can just grab the LED over here, the resistor, and I would like it to be powered, or the relay is a 5-volt relay, so I also need a 5-volt net. So let's have that up here. And I would like, when the relay should be activated, it should be pulled to ground. So I can use a transistor for that. I will use the BC517 or 817 when it's an SMD part. And let's put a ground symbol. Like that. And wire. It's also important to remember protection of the coil. So we'll just place a diode in reverse here. Like this. So, and we want our diode here to be placed in parallel. And I would like a yellow LED. Something like that. And of course we need a resistor, and I would like also to have a pull down resistor here on the input for the transistor. Like a 10K pull down resistor. So they are on the same line here. And I could just grab a 1K resistor for the BS resistor. Like that. And we'll put a label on this pin. Relay would be a good name, I think. So we'll also have that. Save. All right. So the last thing we need, that would be the RS485 interface. And let's take, I would like to connect it on a 4-pin screw terminal, so that I have in the A and B signal, and I would like also to have the possibility of ground and 5 volt on that connector. So place symbol and a screw terminal, a 4-pin. And the signals, I would like to have some protection. I would like to have 10 ohms in series with the A and B signals, and I would like to have a protection for transients, and I would like to have also like a 120 ohms resistor for terminating the line. So let's try and design that. So let's pull out the A and B lines. Like that. And then I would like to have like 10 ohms in series. R and duplicate that one. And let's put a label on. This will be the B. And the A. And we need the protection, or the transient protection. There's this SM712. Let's put it right here. And we just need to put it on A line and B line. And we also need to connect it to ground. Like that. And we can also put the power on here on the transceiver. Like that. And then of course we need to have the terminal, or the 120 ohm resistor for terminating the line. Just get this in a bit. File save. So, and we want to be able to enable and disable that, so we'll just use a small pin header, 1x2, and we can just connect that to 2 different lines, and then we need a 120 ohm resistor. Ohms. Something like that. Yeah. So let's connect the signals to the screw terminal. I like to have ground right here. And I would like to have 5 volts. This one. So let's grab 5 volts from here. And then we have the RS485 signals. Label A and B. And finally we need to put signals on the transceiver. And we of course need to put power on the transceiver itself. So we need like a decoupling capacitor, 100 nano. And power 3.3 volts. Can grab it from here. Like that. And then finally we have the signals. So the part that I normally use for RS485 is the GHVD 1406, and that part has built-in direction pin, so we just need to tie these ones to 3.3 volts. So let's do that. And then we just need the UART to be connected here. So that will be a label and UART. I can maybe find a UART 0 RX pin. This is the RX signal and the TX signal. UART 0 TX. copy those. So a lot of stuff. I think we need to arrange this a bit and make some boxes and put some labels on them. One thing we also need in the net is some mounting holes. I would like to have 4 mounting holes. So let's put those on as well. Like that. And let's just call it hole pad. And we need to connect those to ground. So let's grab a power symbol and duplicate these. Like that. And save. And let's try and connect some of the signals to the Pico. So we have a view here of different pins where we can place them. You can see the UARTs, they need to be connected on special pins, and the I2C pins and the SPI pins. And the power pins, of course, they cannot be changed. And neither the run signal here. So let's just take the UART 0, that's on GP 0 and 1, and the TX is on pin number 1. So we have that one. Just make it a bit shorter. Like that. And then we have the RX pin. Like so. And then we have, maybe we could put the SPI port on here. And that's SPI 0, yes. Let's have a look. And we have SPI 0, yeah. Clock, TX, RX, and chip select. So clock and TX. And we need to pick them from up here. Duplicate. And the first one was clock. And TX. And RX. And then chip select. Like so. And on the next ones we can put I2C here on GPIO 6 and 7. And we have I2C here. Let's see if they can be on 6 and 7. Oh, sorry, 9 and 10. And we have I2C 1. That's pin 9 and 10, yeah. And let's just rename them as STA1 or I2C1, like that. And then we need to do the same up here. That. And let's take the LEDs and move those over here, and we could do the same for the dip switches. We just need to put the relays on here and the switch. Nothing at the relay. We go here to GPIO 11. And the switch could go to 13. Like so. And then we have the LEDs. Let's just take and remove the wires here. So the blue, let's just have that on the last one here. And next one here. The green. Like that. And then the red, the last one, we can put it here. And a wire. Then we have the dip switches. Can just put them on the next ones here. We need 4, 1, 2, 3, 4. Like that. Then we have 2 more open pins here. We can just, what can we find? We can find GPIO 26 and 27 maybe. Put label on. GPIO 26. And GPIO 27. Save that. And we can take those two labels, duplicate them, and place them here. And then we can just mark the remaining pins here as no connect. Then we nearly used all pins. There's a few left here on the left side. Like so. So let's try to arrange everything and put some labels on. So we will just place a line, draw lines, just try and make one here. And place one line over here. Then we have the mounting holes. We could have these down a bit here. And that's I for line. Then we have the LDO. Then we have the input power here. It just makes the schematic a bit easier to read. And then let's place a line here, I. Maybe I should move that down a bit. That. Okay. Could arrange these in a million here. Like so. And let's put some text on. And we will call this DC to DC 24 volts to 5 volts. And what about maybe make this 100? And let's go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Something like that. And this will be LDO 5 volts to 3.3 volts. Okay. This will be just user IO. We will call this mounting. And let's see, maybe we could divide this as well. Just need this to be a bit closer to the edge. If we place a line here. Fine, and then we can make an equal division here maybe. Something like this. Maybe we need to move this down a bit further. Try to make a line here. And then we can just move everything a bit up here. We could make this go a bit more down. So this is approximately in the middle. Then we could take everything here and move it down a bit. I think that looks quite nice. Just need to arrange everything so that they are aligned in the middle. Approximately. Like that. Like that. Let's put the last labels on here. 3, 4, 5. 1, 2, 3, 4, 5. Two, 3, 4, 5. 1, 2, 3, 4, 5. Duplicate that one. And we need the mounting down here. One, two, three, four, 5. 1, 2, 3, 4, 5. And we will call this Pico. And we have the option of the wireless. And we have a dip switch here. And this will be I/O pins. And this will be I2C sensor plus quick connector. One, 2, 3, 4, 5. 1, 2, 3, 4, 5. And this will be relay. And finally, we will have the RS485. All right. Sorry. Like that. I actually think that we are close to be finished with the schematic design. Let's save it. So we have the power input. We have the LDO, 5 volts to 3.3 volts. Green LED. We have a user input switch. And we have a user RGB LED. We have mounting pads. I/O pins, dip switch, the Pico, then we have the quick connector, and the temperature and humidity sensor. We have the relay with the corresponding yellow LED. And we have the RS485 interface and a screw terminal. Yeah, I think we are complete so far. So let's save it, and then we can go to annotate the schematic. Just the entire schematic, and in the Y position here. Then we can see it all starts up here. There is a connector that's a bit higher. This is J1 here. That's fine. But you see everything starts with the lower numbers here and it ends with the higher numbers down here. And I will just rename that part THVD 1406 ER. So before we can start the PCB layout, we need to make sure that we have all the correct footprints assigned to the parts. So let's have a look here in the edit symbol fields. And we can see that a lot of them have no assigned footprints. So we could take and do that. So what do we have? So we have some 10 micro capacitors. And I would just like a 0805 package for those. I think I have a library down here. And why not take the ones that are where we can hand solder it. And the 2.2 micro. We will also use a 0805 footprint for that. The 100 nano, that will be an 0402, also hand solder. The 22 microamp or 22 microhen or microfarads, that could also be 0805. Then we have the transformer, that could be an SMA package. SMA, that one. And the diode LL41, that's just the minimal package, that's fine. So the LEDs, I would like to use just an 0603. And the LED 0603. And let's do that for both of them. Yellow and green. It's fine. Then we have the Schottky diode, and that's also fine. And the RGB LED, that's also fine. The protection for the RS485 line, SM712, that's fine. The fuse, I would like this 2920 package. mounting holes. I would like some 3.2 millimeter holes for that. Like that one, yeah. And we have a 4-pin connector. That's the quick connector. And this is the JST connector here. Yes. Something went wrong there. So something went wrong. Let's try to look at this symbol here. So apparently something went wrong and they forgot everything, but that what happens. So let's load some symbols again, and let's take the 0805 footprint for that one, and that would also be the 0805, and that would be the 0402, and that would be the 0805 again. And these were okay, and the diodes would be LED 0603. And let's just take this one and we can copy it to that one. Apparently not. There's something wrong there. So let's take it this way, like that. The fuse 2920. And the mounting pads. And the JST connector. And the barrel jack. And then we have the connector for the SPI. That's just a generic 10-pin connector, pin header, 2x5, screw terminals, and this was 3-pin I have here. And when it's with the big power, I need this one with the 5mm distance, and for the RS485 I can use a smaller one. And this is just the pin header for selecting the 120 ohm the resistor for terminating the RS485 line. So pin header 1x2, and this is the SVD programmer. So this is 1x3, and the solar jumper. And this looks fine here. And the relay, just to make sure this is the right one. Like that. Then we have the resistors, and that will be, I think that will be 0402 resistors for all of them, except the 120 ohm resistor. I would like a 1206 for that one. And maybe the 0 ohm resistor would be like an 0603. And this would just be some hand solder 0402. Resistor 402, that one. And also 0402. 0402. Then we have the dip switch. That one, yeah, SMD. And I think for the reset button I will use this one. And for the other one, see, we have two switches. And I just need to check the schematic. Let's apply this. Say OK. So switch 2 is the user one. And switch number 3 is the reset one. So number 2 should be a through-hole one. So I would like to use this one, like that. And there's a footprint for the DC to DC converter. There's one for the Sensorion temperature and humidity sensor. So we need one for the LDO. And that's a SOT 223. That one. And the Pico. Let's just check out what we have. That'll be that one. And an SO8 package for the transceiver. That one. So it seems like that we have all footprints assigned. So let's just say apply, save schematic and continue. Okay. And let's just save everything here. One more thing we could do while we are in here defining all the parts is to go to the tools again and edit symbol fields. So you see we have a lot of data here. What we don't see is if we want to order some parts. Let's say we want to order the parts from Mouser, for example, or from LCSC, then we could also insert those labels here. So let's just see, the footprints, can remove that a bit. So we can just insert some new fields. Let's try and insert one called Mouser. and we will also like to have LCSC, so we can find part numbers for these components and insert them here, and then we can generate a bill of material when we are ready to order all the parts. So I just have here, you see I found the relay here, the Tyco RT314005, and you can see here there is an LCSC part number here. So we can just copy that, and then in our simple fields table here, we can go to the LCSC part number, and let's find the relay. It's here, and then we can just paste the part number for LCSC in there. And we could also find the Mouser part number for the relay. I already found it here, and you see there's a Mouser number here. We can just copy that one, and then insert it here. Like that. So this is a quite big job to find all the part numbers. I'll do this off screen, and the files you can download from PCBWay or from my GitHub repository, there you can find all the numbers. They will be inserted there. And you can also download the bill of materials, of course, the complete one. So let's apply this and save the schematic and continue. So now we are ready to start the PCB layout. So let's take a small coffee break, and let's return a bit later. See you later. So let's get ready to make the PCB design. But before we continue, I can just show that I inserted all the part numbers from Mouser and LCSC. So you can see everything has been filled in. Apparently some of the parts are not available, but then you can maybe find them elsewhere. And you can also from here just make an export, and then you can have all the data as a CSV file, and then you can upload the bill of material to Mouser, and then you can actually fill in your basket very easily. Alright, so let's continue and try to start the PCB editor. So we will just update the PCB from Schematic, and then it will load all the symbols, and it will give us some warnings or errors if something is wrong. And we see there is 0 warnings and 0 errors, so we will just update the PCB. And we see that there are 2 nets here that are not connected, and that's on the quick connector, and that's fine. And here we have all parts in the design, just in one big mess. And the first thing we will do is to define the outer, the layout of the PCB. That should be like an 80 by 80 millimeter PCB. And then we can try and drag and drop the most important parts, and then fill in the rest a bit later. And we see that the grid size is 0.1 millimeter, and I would like to make the edge cuts on a 1 millimeter grid. So we can just try and move this to a side, and then we will go to the edge cuts layer, and we will place a rectangle and that should be 80 by 80 millimeters. Like that. And we can also change the corners. Shape modification and fillet lines, and we would like the radius to be like 4 millimeters as a beginning. Then we can see we have some very nice rounded corners here. And if we just take everything here, move it inside, then we can have a look on the 3D viewer. That we have all the parts in here. And you can see there's something here, board outline is missing or malformed. And let's have a look on what the problem is. We can just close the 3D viewer. And the reason this is happening is because there is a piece of edge cuts here in the module, and we have to have a continuous line. So we need to do that, and we'll have to break this line and remove some of it and redo it again. But let's take everything out here, and let's take the module and rotate it a bit. And I would like it to be up here somewhere. First, I would like to insert mounting pads or mounting holes. So you see this aligns perfectly here with the rounded corners. Like that. It's very easy when we have like an 8 millimeter or 1 millimeter grid. Like that. And then we can continue here on the Pico module, and we need to change the grid size a bit. Let's try 0.1 millimeter as a beginning. And maybe we need to go even further down. And we can remove the line here. Let's see if we can grab this one. And connect it there. Draw a line. Like that. So hopefully we now have a continuous line. And yes, nice rounded corners and everything. And we have all the parts lying out here. Perfect. Let's continue dragging some of the parts in. I just need to remove that label there. 1 second. That. Like that. So let's take the most important things we would like to have, or we could just change the to 0.1 millimeter. The DC power jack around here somewhere. Then we have screw terminals. That's for their RS485 line, and then we have for the power. For the relay. And let's take the relay as well. And we can see this aligns very nicely here. Perfect. Just move it a bit further out here. Yeah, and I need some text on top of the relay and also on this connector here. And other important things, we have the quick connector. Could be something around here. Then we have the I/O connector. Place it around here somewhere. Not too close to the USB connector, or else we cannot insert it. Then we have a user button here. Something like this. Then we have power, the DC to DC switcher. Something like that. Then we have a dip switch. Let's place it around here. I think that's fine. Then we have an LED, the RGB LED. Let's place it in here somewhere. Maybe this should go further back a bit. That. Then we have the humidity sensor. Why not around here? Fuse. And you can also see, if we go to the schematic, we can also find some of the parts. Let's say if we need the parts for the relay, then we can switch over here, go for the relay, just mark all the passive parts, like that. And if we go back into the PCB, we can see these parts has been highlighted. We can just say move, and then we have all the parts that are related to the relay. We can just drag them a bit together. Like that. and place them here around the relay. And we have the LDO around here. Maybe we should take these parts and move them up here. Then we have a pin header for the resistor, the termination resistor, and there should be a 1206 resistor somewhere. I think this is this one. Yeah. And we have this diode that gives power to the module from the 5 volt. Let's place it around here. And we also have the 0603 resistor. Maybe this is R17. Let's place that here. Just move this a bit further away. Like that. And here we have the SVD port pin header. We can just place it up here, approximately around here somewhere. And we have a switch, reset switch. And let's place it around here. There's a ground pad there. Let's place it over here. Like this. And we have the transformer. And let's see. It would make sense to fit in here. Like that. And we have an LED. That's a power LED. And the corresponding current limiting resistor. I think we can place it near the LDO up here. As a starting point, it could be here. And then we have the RS485. And it would make sense to have around here somewhere. Let's see. Need to rotate it a bit like that. And then we have G7 here is a protection. And we have 2 resistors. This is see, this is 10 ohm and this is the other 10 ohm resistor, so we can just grab those and move over here. Then we have the resistors for the dip switches, the pull-up resistors, and we can just go to the schematic and highlight those. that. And then we go back here to the PCB. And we can move them together. And we want them to be placed on top of the DB switch here. This is just a rough indication of where the part should be. Let's have a look on the I2C interface. And we need those resistors, this one. And let's switch back. And we can place them together here. Like that. We need these parts to be close together. Then we have some capacitors for the LDO. Approximately there. And we have 2 for the DC to DC converter. We need to fit that in here somehow. Can maybe move this down a bit further. That. And then we have the 24 volts. Coming in right here. And the 5 volt output capacitor. Let's put it somewhere here, I think. Like that. Like so, and those capacitors, we can also move them like that. Like that. So the remaining parts here. So let's have a look on it. That's for the LED, the RGB LED. Have 3 1 kilo ohm resistors here. Just place it in proximity. And this is a pull-up for the switch and the capacitor. Like that. And we can place it over here. like that. And then the final part we have here, C7. Let's just have a look here in the schematic. C7, that's a bypass capacitor for the RS485 transceiver. Let's place it here somewhere. This should be down here, around here somewhere. Yeah, and this is a LED for the 3.3 volts. That could be around here somewhere. Let's save that. And let's just have a quick view on the 3D viewer, how it looks. That's cool. We can see we have some models that are missing. We can take that a bit later on. It's not so important for doing the routing and so on. I think that's good for now. So let's try and route the most important things here. I would like to have some labels on the connectors, so I need to move this a bit further up. So I would like to have something here on the silk screen. Place line. And it should go up a bit here. Let's try it here. And I would like to write, the function for the relay here. So this is the common. Draw some texts. And this should become. And maybe a bit larger. 0.5, 1.5, and 0.25 maybe. It should be a bit further down this. And this is the normally closed. That. Duplicate. 1 second. There's just a postman coming by. optog video, det var derfor det var undskyld. Tak. Det var and this is normally open. And let's see if they are placed. Yeah, this looks fine. Like that. And over here, we can just try and copy the heights. Place line. And on this we have B. And we can maybe just copy this one, duplicate. So this is the B plus. And A minus. Then we have the plus 5 volts. Gets a bit too big. And then I think I need to make this just as one. That. And then here we have the ground. Right. Approximately something like that. So we can try and draw the lines here. That's just X. Like that. And I want these lines to be quite thick. Let's see, 1 millimeter. I think these could be increased to 2 millimeters. that. And I also want to have that on the backside. That's awesome. We can move this away a bit. And I want to have a keep out zone here. When we're dealing with mains power and so on, then I would like to have an area without any copper. So we can place a rules area, and let's go into 1mm grid again. And it should keep out tracks, it should keep out fill zones, and on all layers. I think this should be enough. Like that. So when we make a pour, then there should be no wires or any pores in here in this area. Let's see if they disappeared the red wires on the top layer here. Like that. So strange that this disappears route. It's strange that it disappears. I need to check that a bit later. Let's continue here. I would also like to put a label here that it's a bit, there's some danger. So we can place a symbol. I think I have a library down here. This one, for example. So I just need to grab all this. That. Let's have a look here on the power. And start to route that a bit. and we need to switch to the top layer. Just go through here. Like that. And the firewalls like that. And the firewalls, we need to go to the LDO as well. So we could have a wire here, wire here, and then we could move out to a 3.3 volt layer, put a via there, V for via, and we can put a via here for the firewalls. Then we can switch to the bottom layer and then put a wire and then go up here to the firewalls. Like that. We can just set up the board. So we need a 4-layer board. So we can see there's already a 4-layer board here. So that's fine. Then we can just make a pour for the 3.3 volts. And we will go to a 1mm grid. And then we'll place a fill zone. And that will be the inner layer, layer 2. And we will have a 3.3 volt layer on that one. And we want to have 0.25 millimeters for the relief gap and the spoke width. Okay. Then we can just define the outer perimeter. Like that. And then we would like another one for the ground layer. So that should be, we will put it on the top layer and we will put it on the layer below top layer and the bottom layer and not on the 3.3 volt layer. And we would like it to be with ground like that. And that should also be like 0.25 millimeters. Like that. And then we can just do the same again. Like that. And then if we press B here, then everything will be poured, and you see the rule that we made for keeping out any flood around the relay, that it actually works. There's also another opportunity if you want extra safety around the relay to put on a gap, and I can just show you how to do that. If we go to the viewer, 3D viewer, then you see the design here. And let's try and place a gap here. So you go to, let's go to, we have to set up here the edge cuts layer. And we want to place a rectangle. Like that. And if you press B, then we'll update. And we will go to View, 3D Viewer. And here you see a nice cut here. And you can just specify where you need some cutouts in the PCB if that's needed. Let's close this again, and we can remove this. And you see the distance here, there's 1 millimeter per division here, so there are more than 3 millimeters. So that's fine. We can maybe just extend this one more millimeter. And let's try to we can turn down the zones a bit. So like that. And let's try to make this a bit larger. Like that. Now we have more than 5 millimeters, that should be fine. So we have the power over here. I think we should, yeah, you can see this is then going to the 3.3 volt layer. And if we turn this on a bit, objects and then zones, you can see it is connected to the 3.3 volt net below. So let's make those lines a bit thicker here. If we want that to be 1 millimeter thick. And we can maybe take multiple. Properties, and let's make them 1 millimeter. And of course we need to place some vias close to the decoupling capacitors. And we need to go to another grid size, 1.1 millimeter. Like that. And this is a through hole part, so that's fine. And this connector is also through hole, so that's also fine. And we can just go here and place a VM close to it, like that. And then let's put a VIA here for 3.3 volts. And connect the diode and put a VIA down here. And the shortcut for a VIA, that's Control-Shift-X. Like that. Okay. So let's see the power for the relay and how to turn that on. So we have the most important part is this diode here that will protect the coil. And we'll place that close here. And we need to go to the top layer, like that. And we will go in here like that. We can just switch to the top layer. And there's also 5 volts going down here to the connector. Can just route that on the bottom layer, I think. like that. And then we have the firewalls over here. Can grab it from here. And like that. And we could also make these lines a bit thicker. Let's make them 0.5 millimeters. And the ground is connected to ground, of course. It's a through-hole part. So let's see what we can do here. The power for the relay, the switch. There's plenty of room here. Then the collector will go down to the coil. Like that. And then we have the LED. It's also energized from there. Just move the label over here. It's the label that I want to grab. There's a pull down resistor. We need the series resistor here. Like that. Something like this. Let's see if we can route these tracks X. This could move back a bit like that. Like that. Let's see, we have room here for the RS485. And the two protection resistors. Like that. I actually think I want the area around the labels to be clear of any tracks. So I could just move those up a bit. And place a wire or a track via like that. Like that. Then we have the protection diode. Doesn't work. Like that. Something like that. And then we need to go over to the terminal, the 120 ohm resistor here. Could be something like this. And then we can go on the back side here. Like that. And like that. And we want to go here. We can just switch the layers, then it's easier to see what we should do here. Just drag it up here. Put the label down here. Let's see if we route this track. Like that. That. Need to have some space for this to be connected to ground. I can just place a via right now. And let's connect some power to the transceiver. And we can just go to the bottom layer here. was not so pretty. Like that. Shift Control X for via. And we could also place one here. Like that. And we have 3.3 volts connected here. Like this. So everything is coming together. What do we need here? We need 5 volts for the limiting resistor for the diode. And we can grab it from the bottom layer, I think. Like that. So we can concentrate maybe a bit on the RGB LED. So we have 3.3 volts coming in here. Just place it here. And then we can move around with the resistors here a bit. Like that. And then we have this circuitry here. There's also room for this. Ground. And this could also be connected to 3.3 volts. Let's see, they are close to here. We can try and route them on the top layer. See if it's possible. So maybe we should just move down to the bottom layer here. Because we also need to get the dip switch signals out. That's a ground, that's one more LED. And that should switch to the top layer. Like so. And here we have the switch. Just move to the bottom layer. And let's see how to get over there. And we would like that to be in the middle here. Drag. So it's possible drag. Like that. Fine. And we could then focus maybe here on the dip switch. We have all these lines, they are connected to ground. That's fine. So let's look at these pull-up resistors. These need to be swapped. I think these are online. Yes. And let's try and route those. And drag this a bit and then round this corner a bit like that. Like that. And the last one. Like that. Just make this a bit prettier. Like this. And we need a 3.3 volt via here. We can just connect those together here. And we have the power going in with the unused resistor here. Just place its own via here. And this will be like a 1 millimeter track. And the same goes for this one. And this one needs to go to 5 volts. So I think I will need to put this as a 1 millimeter. And then attach it over here. And you can just press U, then select the whole track. And say properties 1 millimeter. That's it. And then we have some lines here. This is the UART. I think we can just go to the bottom layer. Let's draw a track here. Yeah, we need to see how that should be connected. So now we are up here with the signals, then it's easier for us to see what to do. So this is actually quite easy. Can delete this again maybe. Just move this down a bit. Drag that down. And this should be connected down here. Like that. Like so. Then we have one wire going here all the way up to the relay. Let's try and see what we can do about that. Let's go to the top side for that one. And then go through here to the relay. That. And then we can route the SVD port. Just want this to be in the middle approximately. Can move this connector a bit. It's really nice. And this is ground. You can see this connected to ground already. Then we have the reset switch here. Maybe we can just run that on the top layer. Right. Then we have the GPIO pin header here, and those are already connected to 3.3 volts and ground are already connected, so we could just route these pins here. Let's try and see where this ends. So they need to go down here. Okay. Maybe we should take the SPI port first. Let's see where this ends. It's over here. Fine. Could just take a mirror and put on there. This Mosi. Like that. Then when the clock. Like that. Then we have the two GPIO lines, and we have the SDA lines crossing as well. So let's try and move in the upper layer with the GPIO pins here. And it's a bit tough to get in here. Can just try and go down here. And the same for the other one. See what we can do. Yeah, we can go down here. And up again here. Like that. And there should be room there. And then we can go to the bottom layer. Like that. And we can just drag this down here. Like this, and then we can move this a bit further away, like that. We just need to see how we can get the I2C signals out of there. But we can do that maybe on the bottom side. Drag those out a bit here. That. And now we have the I2C signals out there as well. So the last thing we need to route is around the quick connector here. And let's see what makes sense. So we want the SDA and SCL signals to go this way. If we take those parts a bit further down, or just away from here. Maybe move this up a bit. Like that. Then we have some power going in here. Take this label or designator. Put it right there. And we could make this a 0.5 millimeter of thickness. That. Yeah. And we could just turn off the zones like that. And then we have the SDA and the SCL lines. We can put this right here. Then we have the solder jumper. And we could have the decoupling capacitor. Yeah, let's check it out. What we have here, ground. We have the reset pin. So that should be connected to a 10 kilo ohm resistor that we have over here. And here we have the 10 kilo ohm resistor. Let's try and see where it would make sense to put it. Just put it right here maybe. Take all this a bit further over here. Place a wire. We have 3.3 volts and we need the capacitor. This was this one. And we can place it right here. The label. And the via to 3.3 volts. And we have two ground symbols here. Can just move them out to a via. Like that. And also this one can go out to a separate one up here. And then we have the address selector here. And the solder jumper. And we have a via to 3.3 volts, and then we have pull-up resistor. Pull down resistor, sorry. And a via there. Then we have two pull-up resistors for the I2C port. Let's place them just here. And we have the SCL line as the first. And we should have a via here as well. And then the SCL line and the SDA line. And should continue the SDA line up there. And should also go there. Then we have the SCL line. I think I need to move those a bit away, like that. And that should be on the top layer. And we need to switch layer here. And here. that. We should move this a bit in here, like that. And then like that. And let's see how we can get hold of the SGL line here. Let's do it like this. And then we can just connect it there. And then we need 3.3 volts here. Like that. So I think that makes it for the routing of the board so far. So let's just have a look on the 3D viewer. It's cool. We need to make an update of the flood filling here. And let's just try and take a small break. Yeah, and let's continue. I think that we have all the parts have been routed. Let's pay some attention to the silk screen and see if we can put some labels on and see if everything is making sense. Maybe we should move this around a bit. And we could just switch to the silk screen layer. Like that. C2 here. There. C3 could be here. D1 down below here. And then we have C6 could be over here. This looks fine, fine. Maybe if one is a bit close to the edge. Like that. These resistors, they are fine. J3, that's fine. Take U5 and, oh sorry, U5. Put it right there. And the relay. Could be right there. So I want to put a bit of commercial on top. Draw or place footprint. It's a symbol. Like this. Place some text. Maybe this should be bold. Maybe 1.5 and 0.25 maybe. Duplicate and say this is revision 1.0. Like that. Or should we do that in capital letters? We could just maybe do it below here. Something similar to this. We could also turn on the bottom layers or the filled shapes. They are good in the zones. Let's put them on like that. B. And then could arrange this to be on top of that. Like that. And we have this, that's fine. And maybe we could also put some labels here on the connector up here. Need to move this a bit, I can see that. Like so, and let's put some text on here. Place texts, and we would like to have plus 3.3 volts. And duplicate that one. And we want duplicate again. GPIO 27. GPIO 26. Duplicate. And that's chip selects. And we can make a tilde and tilde to work chip selects to work end like that. And this is ground. Okay. Duplicate that one. Duplicate. duplicate. And this is the TX line. This is motion. SEK. This one. And I think that the size is a bit too big. Then we can say just text. Properties. Apparently I have to do that for, that will be, we'll just keep the size then. Oh, I'll make it 0.75. See how that looks. It's a bit too small. 0.8. Then we will keep it, and then we'll just rename this one IO27. IO26. And then we can just align it. And align to button. Like that. Move it a bit further away. Like that. We can do the same for this. Top. And move it a bit further away. Like that. And there we can see we need to change the net from this one. Just have to select all items, and this is H4. The schematic here. So we just need to do that and place no connect. Like that. Save. And then we can say tools, update PCB from schematic. And now that's gone, that's fine. And we want to place some text on the backside. I think we could place, let's switch to the backside, silk screen. And let's place symbol. And we have this one. And flip. And we need to enable the silk screen, of course. And we could just put it here. And let's have a look on the top side, and then just take those two things and duplicate that. And flip those. Like that. And we can put it here. Duplicate that. And then we can just say powered by. Powered by YouTube. Made by Morten. And PCBWay.com. And we could put it somewhere here. And let's go to the top layer. And we could just place some extra ground vias. So let's see if we can find some vias. Move that one a bit up. Duplicate that one. Then make sure that all the layers are tied properly together. Like that. And we just need to move that label there, I can see. Alright, then we are ready to make a design rule check. Just save it, and then we can see if there should be some major issues. And we see we have 0 unconnected items, no violations, 0 errors. We have some warnings, and those are something with the silk screen, so they are not really important. I can live with that. So perfect. We can just have a look on the 3D viewer. Let's update. and maybe we should find the remaining parts. Can just show you how you can do that. I have all the 3D models, so let's try and see what we're missing here. So we can take the Pico module here, and take 3D models. Then add, and let's see if we can find one. And we need to flip it a bit. Like that. Move it down in the Y direction. It's very hard to do when it's such a large module. Seems to be something that are a bit off here. Maybe and then a bit further down. I think that's fine. What about the height? It's perfect. Let's just have a view and see if it's there. Yes. So we have the LED and the fuse and a few connectors. There we have the LED. There we have the fuse. Let's see if we can find a model for that one. Fuse. It's not that one. I cannot remember where I have that model. Let's just take one of the other ones then. And remove that one. And just go to this connector. And we need to also move that in the X, not the X direction. And it should go a bit higher. .3. And then we can see that. Then we have to connect up here. And this is a quick connector. Like that. This looks fine. Maybe it should go back a bit. Like that. Then a bit lower. That. And let's take a 3D view. Alright, there's only the humidity sensor and the fuse here missing, but that's fine for now. So here you have the final design. And we are ready to ship the design off to the manufacturer. Save. And you see I have one of the plugins here, the PCBWay plugin, so I can just press this button, then it will automatically zip all the files. But in the meantime, you can just go to File and then Export or Fabrication Output, sorry, and then go to Gerbers, and then you can make the Gerber files for all the layers you see that are put in here. There's a plot and generate drill files, and then you have all your data. You could also go in here and in the schematic design, you could also plot the schematic to a PDF file. Just go to File, then to Plot, and you say, okay, I want a PDF file, output directory, that's just where you are at the moment, and you could plot current page, and then you have the PDF file. You can just see you have your zipped file here that the PCBWay script made, and you have the PDF file here that was generated by the schematic plotter. So there you have it. The design is ready, and I hope you enjoyed the video. See you in the next one. Bye.